Hi everyone, my name is Noah Stevens. I'm a co-founder and lead developer at 3D Wave Design. I'm just going to share my screen now. Screen one. Okay. And I will start the presentation. Yeah, so what I'm focusing on today for my talk is democratizing data and what that means for the end user, and how it can be used to empower people for understanding climate data and emergency management. So yeah, my talk, I'll go over a bit about us. I'll dig into what exactly democratizing data means for us as a company. A little bit about the technology behind what we're doing, examples of real-world application, and I'll do a demo. So yeah, a little bit about us. So 3D Wave is an indigenously owned and operated 3D animation and software company owned by Stevens Solutions and Design. My father, myself, and my wife Lena Ali created 3D Wave Design. Essentially, we were starting off doing 3D animations for industry here in Atlantic Canada and also over Canada itself. Our niche was we essentially helped communicate information that could be used at conferences or for sales. And so that was our expertise. We sort of combined all of our talents. I was working in the film and television industry for a while. My father, Barry Stevens, was an electronic engineer, and my wife, Lena, was a journalist. And as we started looking into other avenues, we began to look at climate information and climate data and how that was being communicated. And that's sort of what brought us to this point with 3D Wave. Our mission as a company is to make complex information accessible and engaging, and our vision for the future is to continuously use innovative technology for the advancement of sharing knowledge. And you can see these two little pictures here. This is some of our technology in action. That's a real-time fire simulation running for an Acadian First Nation community. It's based off of Byram's fire equation, so it is pretty accurate depending on the input data that we feed it, and we are looking to rigorize those simulations with Natural Resources Canada. We currently have a grant with them, and we're looking at converting over their Prometheus system. And to the right of that, you can look at another example of some of our software running. This is actually used to ingest LiDAR and GeoTIFF digital elevation models and view it in virtual reality. So what does it mean to democratize data? Well, you can see examples pretty clearly if you go on GeoNova, for example, their data locator. The province has flown LiDAR pretty well all over Nova Scotia, and it's incredibly easy to get access to that data. However, for a typical user, there is definitely a technological barrier that exists. You need a pretty powerful computer with a graphics card. You need to understand geospatial software like Cloud Compare, and even at that point, it's sort of in a point cloud format. So essentially what we're trying to do is to make a platform or intuitive technology that removes that technological barrier. It's platform agnostic, so we build our technology with a web focus, but we also do native applications for Linux, Mac, and Windows, so anyone can get access to this. And we try to make the data relatable, photorealistic, so that when we actually talk about showing inland or sea level rise or fire simulations and other environmental data, you actually get sort of a photorealistic representation of it. So it's complementary to the actual numerical data that we also provide in our applications. So yes, like I said earlier, our technology is web-based. We use a lot of open source code to build it. Early on in our project, we actually partnered with Tim Webster and his team at COGS with NSCC, and they helped us early on develop some of the ingestion technology for bringing in LiDAR and visualizing that in the web. So yeah, the real-world application for this stuff. So essentially, we're looking to bring together all these data sets, partition it and organize it for people to understand, represent the data in photorealistic 3D for essentially communications and tabletop training. So we've targeted emergency management personnel and professionals, visualizing First Nation communities, and we've also done projects and contracts with municipal, provincial, and federal government decision makers and policy analysts. And we're also looking to further our technology to actually be used in more of a data processing sense. So we've worked with and built LiDAR point cloud and geotiff ingestion, bringing in really intuitively 3D lighting, so you can basically highlight the contours a little bit easier. Clip elevation, for example, and that screen capture that you see on the right for highlighting folds in the earth if you were looking for synclines and anticlines. And also for further analysis, you can even view all of this in virtual reality and to get that stereoscopic feel. So yeah, that's not quite the end of my presentation. If you can still see my screen, I'm going to just make sure here. Okay, yeah. I'm going to share an example application that we've done. So I will warn you that in early tests, the frame rate seems to drop when I broadcast this over the internet. So I do apologize, but I will try to move slowly and deliberately for this presentation. This particular project that we did was for the town of Lunenburg and also the community of Blue Rocks over here. We worked with the town and also CBCL on visualizing flooding around the wastewater treatment plant and what would happen if we put in breakwaters to protect it. However, that project is sort of covered under an NDA, and what I'm showing you here now is the publicly available version. So yeah, this is all running in the browser. It supports mobile devices. All you essentially need to do is have the link, and you can click on it and view it in real-time 3D. As I may have already stated, it's totally interactive, so I can pivot around the scene like so. These are all digital elevation models that we've pulled from GeoNova as a raster format, and our software in real time parses the geotiff and creates these photorealistic representations, also by combining ortho photos. So as an example of how close to the ground you can get, I'm going to click on the downtown Lunenburg pin. And sort of like Google Maps, it gives you a little abstract here of the town and a picture. And then there's more information here organized on the side, so you can basically toggle other pins on the map to get a ground view. We also organize research papers, references, links to actual real-time weather data. So if you click on Lunenburg weather, you can go right to the resource here. And this will also give you tide charts as well, if I go back. Yeah, Bloomberg Pie Charts. And this sort of helps the user work with the sliders I'm about to show you here. So if I go back, go full screen, you'll probably notice two sliders here at the bottom. So essentially what this does, it gives you access to the tide in meters, which also has a regional offset. So you can see me slowly increasing the tide, and I can go over the normal limit here, which is 2.3, and you can see it's slowly starting to run inland. We have double-checked this on high tide events with the town itself. Our company is run from Mahone Bay, which is very close to Lunenburg, so we've actually driven down there and sort of witnessed this, this high tide scenario a couple of times. And you can also add the storm surge here, which actually affects Back Harbor, which is right over here, a little bit differently. So there's actually a difference. It is a bit of a conservative bathtub model where we are just raising and lowering the water. There is no wave action, but we have accounted for some offsets, for example, like Back Harbor here, because it's in a little bit of a different channel and an inlet. Outside of the emergency management resources that we have here, you can also get access to historical pictures for context and little excerpts about what you're looking at. Yes, and this is the sort of power of the tool right here. So flooding scenarios. So we did this in conjunction with CBCL. So what we're about to visualize, and I'll lower the tide to 0 and the storm surge down to 0. So you can basically select a time horizon and a return period storm, which is a 10-year flood event. In conjunction, these two data sets provide you what you could be looked at as a 100-year flood. So if I, for example, go to 2100 and I visualize a 100-year flood here, we'll see how dramatic that is. And as you can see, a lot of the infrastructure is really impacted, hence why breakwaters are needed. And to also show you just how much sea level rise affects us, I'm going to go from 100 to a 10-year flood event. Not much change, eh? So yes, sea level rise is a big issue. And I'll just show you the difference between a 2020 100-year flood event and what that looks like. Quite different. 2050 100-year flood event. Slightly different. 2070 100-year flood event. And here's where things start to get messy. So yeah, this tool allows people to better understand infrastructure at risk with sea level rise and storm events. Typically in 2D maps, you'd be looking directly down. There wouldn't be a sense of depth. A lot of this would be represented with 2D vectors and colors to represent depth. So we're really trying to allow the user to realistically relate to the data. That's sort of our mission with this technology. And because it's all web-based, for example, you can just as easily take a picture, which allows you to share this to social media. And our maps are scalable, which I can demonstrate here. I can go over to the Blue Rocks area, and you can see everything sort of gets dynamically loaded and parsed and built. So the reason we don't go outside of these bounds is we typically like to work at a municipal or a town level because there are so many factors that we want to visualize or pain points that the town or municipality would like to have visualized. So at the moment, this is the typical scale of a map that we work on. However, our maps or our technology is engineered to work with greater and greater data. However, at the moment, you're looking at a UTM projection, so it's not visualizing the curvature of the Earth. So that will have to be factored in the future, of course. So yeah, that's an example of our flooding visualizations. And let me move on to Medway, which is one of the earlier projects that we would have done while we were working with Tim's group.
Just a 1-minute warning there, Noah.
Oh, sure. Yeah. Here is a quick fire simulation. 1 minute. Okay. Using Byram's fire intensity, I can select a location. I can play with variables like wind direction, dryness, simulation speed. And I can select multiple starter locations and play with those variables in real time. And what this does is essentially provide this First Nation reserve with an emergency management tabletop tool. So it's less about responding to fires in real time and more about educating people at what could be at risk and planning around that. So I believe that's all I need to show at the moment. If I have more time, I can go on or answer any questions. But
do you want to take another, maybe just 1 more minute do you have another tool you want to share with us?
No, the last tool that I'm able to share is our fire simulation. Our Our virtual reality stuff that we had built for the province is sort of under an NDA right now, so this is sort of the last little bit of my demoing. So I can stop sharing.
Sure. We do have time for questions,
Sure.
And if you want to continue showing through your demonstration there while we wait for some questions to show up in the chat.
Absolutely, yeah.
I have a question actually to start. So in the wildfire simulation,
Yes.
You said you're able to play with the wind speeds and whatnot. When would you find that you had maybe that much control over the information that's incoming to be able to know what wind speeds and other conditions are going to do during a wildfire?
Yeah, absolutely. So currently we're working with Natural Resources Canada to rigorize our fire simulations. So we can actually, with the technology that we're working on, fetch real-time data like fire indexes and dryness and all of that stuff real time. However, at the moment, we pre-processed a lot of the data, such as the vegetation and the hills in elevation. So that's sort of static at this point. And we figured out, based off of Byram's fire intensity, a correlation with variables such as wind direction and wind strength and dryness. And those are sort of variables that we let the user change with this particular simulation so they can sort of create scenarios for their emergency management. Does that answer your question?
Yeah, absolutely. I'm just thinking because typically we'll get these data retroactively, recognizing where a fire may have started, and then in real time it will progress. But we don't usually get any real-time data coming in to map fires. So especially in First Nation context, where you might be quite a ways away from where a lot of attention is.
Yes.
So I'm just thinking for a model like this to be practical and useful, you would have to have a general idea of, prevailing winds or something along those lines.
So yeah, typically when we created this technology, the variables are completely open for the user to change. So the emergency management professional would typically go into a meeting or a demonstration knowing the prevalent winds and then input that data here with the slider that you see on the left to do the proper visualization. We like to think of this particular tool that you're looking at as sort of a blank slate, and it's really up to the integrity of the person who's using the tool and teaching the community to use.
That's really fascinating, and I'm finding that if you do see a simulation top-down 2D, maybe a choropleth map, you're not getting the same feel for impact that you are when you're able to zoom in, play around, and see things in that 3D model. It's really striking.
Yeah, thank you. Yeah, that's ultimately our end goal, is to get people to understand awareness, climate change and mitigation and all that stuff. And how you do that is not just by simplifying the data, however that's important, but it's making that data relatable. And that's sort of how we come at this, because that was sort of our expertise as a communications company, is how can we better explain something to someone so they understand the product. And we're trying to apply that essentially to environmental and scientific data.
Are you able to import vectors on top of this?
Absolutely, yeah. So I'm currently working on basically fetching vector data from OpenStreetMap and plopping it in real time.
Really interesting. Are there any other questions there for Noah before we call up Daniel? We'll give you about 10 or 15 seconds to drop your questions or your comments in the chat. It's really exciting. We do have a comment here, a question from Roger Wheat. How up to date is the fuel load data for the fire model to be realistic?
That's a good question. When we were sort of tasked with building this project, we took all of the data that existed for the community and we sort of pre-processed it. And for this simulation, it's really just looking at the trees and the tree type that was sort of ascertained from a site visit and from the LiDAR itself. But we're currently researching fetching the data in the fire index with the new project that we're working on with Natural Resources Canada, which I can only speak so much about.
Right. Okay, well, thank you so much for your presentation, Noah. It's fascinating to see this kind of a tool. I can sort of imagine many different applications for it, not just emergency management, but all kinds of things.